Welcome back to another section. We're looking at LCM of odd numbers today. LCM of odd numbers. We've dealt with ACF of odd numbers, LCM of odd numbers. Let's look at, we've dealt with common multiples of odd numbers also. So let's look at the lowest common multiples of odd numbers. Odd numbers. Example, find LCM of 3 and 7. Using the tabular form, we've already dealt with that already. Write your 3, write your 7, create a space for your factor. What can divide 3 and 7 at the same time? There's no number. So 3 will divide itself, bring down 1, 7. 7 will divide itself, bring down 1 and 1. Remember I told you, for your LCM, if no number can divide all the numbers you're dealing with, then each of the numbers should divide itself. So our LCM will be 3 times 7, and that will give us 21. Using exponential method, you express 3 as 3 to the power 1 and express 7 as 7 to the power 1. There's no 7 here, put the 7 here to the power 0. There's no 3 here, put the 3 here to the power 0. And I said for LCM, pick out the ones with the highest power. In the families of 3, this is the highest power, 3 to the power 1. In the families of 7, here is the highest power, 7 to the power 1. This is your answer in exponential form. Or you can as well express your answer as a whole number from 3 to the power 1 to 7 to the power 1. 3 to the power 1 is still 3, 7 to the power 1 is still 7. That will give us 21 as a result. So we can solve the problems now in exponential form or in tabular form. Whatever method or way given to us, we can apply them in that way. So this is how you solve for odd numbers. For odd numbers, what is the LCM of 8 and 5? 8 and 5 solution. Tabular form. Let me make it 3 numbers for you so I know because if it's 2, 8, 5, and let me say 3. 8, 5, and 3. Tabular form, 8, 5, 3. Put your factor area. What can divide 8, 5, and 3 at the same time? No number. So each number will divide itself. 8, bring down 1, 5, and 3. 5 will divide itself, bring down 1, 1, and 3. 3 will divide itself, bring down 1, 1, and 3. Our LCM will be equal to 8 times 5, 8 times 5 times 3. And when you multiply that, 8 times 5 is 40. 40 times 3 is 120. So our LCM is 120. Using the exponential method, we are going to express 8 as 2 raised to the power 3, express 5 as 5 raised to the power 1, 3 as 3 raised to the power 1. There's no 5 here, I'll add 5 to the power 0. There's no 2 here, I'll add 2 to the power 0. There's no 5 here, I'll add 5 to the power 0. There's no 2, I'll add 2 to the power 0. There's no 3, I'll add 2 to the power 0. There's no 3, I'll add 2 to the power 0. So, our LCM are the ones with the highest power. In the families of 2, here is the highest power, 2 to the power 3, times in the families of 5, here is the one with the highest power. In the families of 3, here is the one with the highest power. So here is our exponential result. When we ask to put your answer as a whole number, our LCM will be 2 to the power 3 is 8, times 5 to the power 1 is 5, times 3 to the power 1 is 3. This will give us 40, times 3 is 120. So this is our answer. Whatever method that is used and you feel is preferable, you can use that method. But this is how we find the LCM of odd numbers. Whenever you don't have factors that can divide all the numbers given to you, then each of the number will end up dividing itself to help you get the final result. Unlike ACF, where if there's no number that can divide, you stop at that place. But they will not stop until arrive at 1 using the tabular method or the exponential method. So carefully go through your class and get the best out from it. See you in our